Hello everyone, in this video we will be solving the question mid of linked list. Now the problem statement says that say we have a linked list of this sort, we are supposed to return the data that we find on this node, that is the middle node of this linked list. But there could be another case. For example, this particular linked list has 5 nodes, that is odd. You could have an even number of nodes as well. So in that case, what we're going to do is that we'll return the value at this node, which is the last element of the first half of this entire linked list. The constraints are that we cannot use the size function in any way. It's not allowed. We have to do this iteratively. And we are supposed to finish this process in a single traversal. That is, we are supposed to pass through each node just once. And now what we're going to do to solve this is, we're going to use an approach known as a two-pointer approach. For that, we take, 2 pointers. One is known as the slow pointer, the other is known as a fast pointer. Say I have my slow pointer here and my fast pointer here. Both of them will be initialized at the head of the linked list in the beginning. Now, in every iteration, the slow pointer moves by 1 position, the fast pointer moves by 2 positions. Then the slow pointer moves here again, and the fast pointer moves here again. And now we see that we're actually at a correct position. So this is the point where we exit the loop. And the condition for that is that the pointer next to the fast pointer is actually null. There is nothing present there. This is the case at which we exit the loop. Let's write that down. Say we have our node slow that points to the head in the beginning. Same goes for node fast. Now we go and update our pointers while this condition is true, and the condition is what we just discussed, that the pointer next to the fast one should not be equal to null. If it is, we exit the loop. And while that happens, we update the pointer by 1 position for the slow pointer, and for the fast pointer we go forward by 2 positions. And once that is done, we return the data that we find on this node, on the slower node. As our answer was found on the slower pointer, we return the data at that particular pointer. Let's try to run this. It will actually give us an incorrect answer because the number of nodes in this particular example are actually even, and we haven't really handled the even condition yet. So say I bring my slow and fast pointers here. I'll show you what happens if this current code runs on an even case. The slow pointer goes forward by 1 position, fast pointer goes forward by 2, then the slow pointer goes forward by 1 position again, then fast go forward by 2 positions, and it reaches null on its own, and the loop ends right there. But actually it points to null. So we get an error there because we are in a place where we can't really point to anything. And so we find out, and also let's not forget that our answer is actually incorrect here. The slow pointer was supposed to be here, not here. So to solve that, we need to stay in a position where our slow pointer is at the correct position and the fast pointer is right here. And this condition is that that fast dot next is null. So we only update our pointers till fast dot next is not equal to null, because if it is, we are at a correct position and we exit the loop. So implementing this, we just have to add one more condition, that is fast dot next should not be equal to null. And on running, let's see if this is correct or not. It is. We're accepting our default test case, and on submitting we will find out that all of our test cases run perfectly, and they do. And that's how you calculate the middle element of a linked list. If you liked this video, if you found this useful, drop a like, leave a comment, and do subscribe to our channel. Thank you so much for watching.